the main point of the practice exam was to get you guys to feel the time pressure and the time crunch and to kind of understand what that's going to feel like on exam day. I hope that'll help to alleviate some of the stress. Yeah, so hopefully that'll help kind of get you guys in the idea of looking at the clock and keeping match of the time and understanding all that stuff. So make sure for the real test that you don't run out of time and you don't forget to submit. Thanks, Lauren. Everyone else too, not just you. All right. Let's go through the practice exam. So I asked 2 questions on the practice exam. They're both 10 points each, which means a total of 20 points were available. That's okay, Maggie. So if you got more than 16 of those points, 16 or more, that's going to be a 5-ish. I don't know exactly the breakdown. Computer did manual restart. Oh gosh, Aiden. So those are all great things to get out of the way before Thursday. Make sure that your computer's restarted. Make sure that you have everything up and ready to go. These are things that we did so that you guys, or that's why I did this timed version so you guys would know that. So, greater than 16 is a 5, greater than 13 is a 4, greater than a 10 is a 3, greater than a 7 is a 2, and less than 7 is a 1. No? No. I don't even know if I'll even grade this, but I probably will. We'll see. I haven't decided how I want to grade it or what I want to do for grading on this. Yeah, so like I said, 16, 13, 10, 7, 7. That's the approximate percentage breakdowns. It's not exact. It'll maybe fluctuate plus or minus 1 point. Anywhere from a 15 to a 17. Okay, so let's get into it. Yes. So again, Isaac, the point of this practice was so you guys could get used to the feel of submitting and doing a timed exam. So, like I said, if you haven't done it yet, just go do it now. Come back. You should be done by the time we're done, if you get it done fast enough. But yeah, so we're going to go through it. Okay, so this was question 1. My phone crashed with 10 minutes left. Okay, so again, these are good things to get out of the way and to understand, just know what to do in case they happen on the actual AP test. I'm going to move this up ever so slightly. There we go. Just a little bit. All right. So, apparently we have this S8 structure. Yeah, go ahead and just grade your own, Lauren. Yeah, grab yours out and then grade your own, and then we can all kind of collectively see how we did. So it says the diagram of S8 shows only bonding pairs of electrons, right? So it shows the bonds. How many lone pairs does each sulfur atom have in the molecule? Okay, so to answer this question, right, we know that sulfur, if we look at a periodic table, sulfur is the same group of oxygen, same group as oxygen, so it'll have 6 valence electrons. So if all of these have 6, one's going to this, one's going to that, that means we still have 4 left. So there should be 1, 2, 3, 4. There should be 2 lone pairs on each sulfur. So how many lone pairs does each sulfur atom have? 2. And that's your first point. Literally 2. So you had to say 2. You got a point for saying 2. Congratulations. Or sad day. Letter B. Based on your answer to part A, determine the expected value of the if we said 4 extra electrons? The question says lone pairs. So I don't know how they would have graded that. Do make sure you answer the question. So lone pairs are pairs. So it should be 2 lone pairs. I'd have to be, I don't know what the grade, they probably had an answer for if someone said 4 extra electrons, but I don't know if they would have given them the point or not. So I can't make that judgment call. So let's say no for today, Isaac. Based on answer part A, determine the expected value. Well, if that means this is going to be a tetrahedral bent, right? So you would refer to our lovely formula worksheet, AP Chem cheat sheet, page 2, right? And you would see that 2 lone pairs and 2 bonded atoms gives you a bond angle of approximately 109. Sorry, I know you guys can't see that. That's really close zoomed in. But the answer is 109. And they accept anything between 104 and 110. So the technical angle is actually 107.8. Ooh. So you just need to say 109.5. Or 104.5, either one. Okay, write the electron configuration for sulfur in the ground state. If we pull up a periodic table, sulfur is, sulfur's up here. So if we wanted, we actually could do, if we had ptable.com, we could actually just pull up the orbital electron configuration for it. Or we could know 1s2, 2s2, 2p6, 3s2, 3p4, right? Read it from left to right, top to bottom. 1s2, 2s2, 2p6, 3s2, 3p4 get you to sulfur. And that's where you get the point. 1s2, 2s2, 2p6, 3s2, 3p4. Or you could have done the noble gas configuration, neon, 3s2, 3p4. 1 point for saying that. All right, letter D, a photoelectron spectrum. The complete photoelectron spectrum for the element chlorine is represented below. Peak X in the spectrum correspond to the binding energy of the electrons of course. The electrons in orbital chlorine have a binding energy of 73 megajoules per mole, while the electrons in the same orbital sulfur has a binding energy of 239 megajoules per mole. Identify the orbital and explain the difference between the binding energy in terms of kilometer. Okay. So, identify the orbital. Wait. Peak X corresponding to the binding energy electron in a certain orbital of chlorine. Oh, okay. So if they have the highest binding energy, those are going to be 1s orbitals, right? We know that we read this as 1s, and then 2s, and then 2p, and then 3s, and then 3p, right? So it should be the same. Did I write this test? No. I pulled it from some former AP stuff. So this is the 2018 alternate exam question 1, basically. Yep. So it's a real AP test question. Okay, so identify the orbital and explain the difference in binding energy in terms of Coulomb force. Okay, so the orbital is an s orbital. The difference between chlorine and sulfur, right, is because chlorine has more protons in the nucleus, and so it has a greater pull on the electrons. What's more positive nucleus, greater pull. It's going to have a higher binding energy. The other thing, you also talk about radius, how the radius of a chlorine atom is smaller than the radius of a sulfur, and so there's a greater distance, right? Remember, whenever something asks about Coulomb's law, there's 2 things, charge and distance. We always want to talk about charge and distance. Thank Luckmeany for the follow. So charge and distance, those are the 2 things. So when we go over to this, they probably said something like, peak X represents a 1s orbital, a chlorine atom has 1 more proton in the nucleus, therefore the electron more strongly attracted to the nucleus. Binding energy is greater than that of the 1s. Oh, these are 1s electrons, so yeah, you would want to talk about the protons in the nucleus. So 1 point for identifying the orbital s, 1 point for a valid explanation. Greater charge. My daughter's doing something. All right, letter I. Peak Y corresponds to the electrons in a certain orbital chlorine atom. There's peak Y. On the spectrum shown, carefully draw the peak that would correspond to the electrons in the same orbitals as the sulfur atom. So this is a pretty tricky question. So again, reminder, this is 1s, 2s, 2p, 3s, 3p. What's the difference between chlorine and sulfur when we talk about their 3p orbitals? If we go to the periodic table, chlorine has 5 electrons in its 3p, sulfur only has 4. So there should be 1 less electron. On a photoelectron spectrum, the height represents the number of electrons. So if you see here, it says relative number of electrons. So this one's all the way up to 6. This one's all the way up to 5 because it's chlorine. And so we should only go up to 4 for sulfur. The other thing, similar to what we talked about in the first one, because sulfur has fewer protons in the nucleus, these electrons are going to be less tightly bound. And so we should have a peak that goes up to about 4 that's a little bit to the right. So somewhere around here we should draw this peak. So it should be to the right and it should be up to 4 units high. So let's see, 1 point's earned for the peak that's to the right and has the correct height. Yeah, she's angry. I'm betting that my wife told her to get off the countertop. All right, now we move on to, we now have this reaction between this S8 molecule and 8 hydroxides to make whatever that is and whatever that is. Oh, it looks like hydrogen peroxide. An experiment, a student studies the kinetics of the reaction represented above and obtains the data shown in the following table. So notice we have initial concentrations, initial rates. D2 is just 1 point, Isaac. Well, actually, it was 3 points altogether. No, wait. Oh, D, Roman numeral 2 was just 1 point. 1 point is earned for a peak that has the height of the correct height. You had to have both things. It had to be over to the right and it had to be up to 4 in order to get the point. So far we've got 1, 2, 3, 4, 5, 6 out of our 10 points. Okay, so we're talking about rates. So use the data in the following table to... You can do it, Mikey. Breathe. So I really think that they're going to be a little more lenient with the grading and the questions will be easier, but I'm not sure. So I'm trying to prepare you guys for the most intensive scenario in hopes that it'll go from there. Yeah, Sammy, give me a second. Yeah, I'll go back to it. Okay, so again, there's 2 things that affect how tightly bound an electron is. Okay, the protons in the nucleus, and then whatever orbital it is, right? So we know the higher orbitals, right, are less tightly bound. The closer orbitals are more tightly bound. So this first peak, the highest energy peak, will always be a 1s orbital. That's on my cheat sheet on this PES section. Right? So the x-axis reverse goes from high energy to low energy. The most tightly bound electrons are the one at first peak. The height represents the total number of electrons. The spectrum is shown for sulfur. So I actually showed you guys sulfurs. So that actually would have been really useful in this because the question asked about sulfur and you would have seen that it would have been around 1. Anyway, so use my reference sheets that I made you guys. Use the reference sheets. If you haven't gotten used to using them, use them. So again, why is it slightly to the right? Because chlorine has more protons in its nucleus, right? Chlorine has 17, whereas sulfur only has 16. Okay, so chlorine 17, sulfur 16. You would have 17 peaks for plutonium. Yeah, because of all the things. And beyond calcium, photoelectron spectroscopy gets messy, and they usually don't use it for elements beyond calcium. But they do a little bit, depending on what the science is. Anyway, so like I said, it's going to be a little bit to the right because it's going to have less energy because there are fewer protons, and so those electrons are further out. Someone in honors did, Micah. Okay. All right, so let's talk about rates now. So the last 2 questions ask about rates. Okay, so we've got our initial concentration, we got the initial rate. It says use the data in the table to determine the order with respect to S8, justify your answer. Okay, so we look at trial 1 and trial 2, and we see as we go from trial 1 to trial 2, the initial concentration of sulfur is tripled, right, times by 3. The hydroxide remains constant, and the rate triples. Yeah, so you could definitely use math to justify your answer. So a justification here would be, if we triple the concentration and the rate triples, then it has to be first order, right? And you could even show it like, I'll show you what the answer says so to put you at ease here, right? So it says, so you can do the math, right? Reaction is first order with respect to S8, comparing trials 1 and 2. Tripling S8 will keep hydroxide constant, result in the tripling in the initial reaction rate. So you can explain it with words, or you could set up the two equations like we've done in class, where you set the one equation divided by the other equation, you plug in, you cancel, and you find that 3 to the x, or 3 equals 3 to the x, and so x has to be 1. So either a mathematical explanation works perfectly, or you can explain it logically. Either one of those is going to get you the point. So, and you can't, if you said first order, you have to also explain it correctly. So if you said first order but with a wrong explanation, you would not get this point. So this is an and. You have to have both to get the point. It didn't even do the whole equation, just S8 and the rate. You would probably want to show that things canceled, Isaac. You probably want to show the full rate law just to show, hey, I'm understanding that this is part of the rate law, but I know it cancels. So it tripled on both. That's fine too. So pick one and then stick with it. You should be okay. All right, letter 2. Determine the value of hydroxide that was used in trial 3, considering the reaction is first order with respect to hydroxide. Justify your answer. So in this one, you would probably want to do mathematically. You could maybe reason your way through it. Actually, no, you could reason your way through it. So in trials 2 and 3, sulfur remains constant, but the rate essentially doubles. And so if it's first order, the concentration of hydroxide would have to double. If you do math, should you explain anything words to or like a box anywhere? You don't have to. If your math is written simple and straightforward, that's good enough. So if you see, so back to this one. If you had just done this, right? And then you just say, I would maybe tack on and say first order, right? Or you'd say it's first order or something. So saying x equals 1 and then saying it's first order would be good enough. Yeah. Okay, and then the second one, comparing trials 2 and 3, S8 is kept constant, initial rate doubles. Since the reaction is first order with respect to OH, the concentration of trial 2 must be double, or 0.02 molar. So you have to have the correct concentration, and you have to have valid justifications. You could show the math to do it, but your final answer should be 0.02 molar hydroxide. Yep, you're good, Sammy. All right, last question. The next day, the student conducts trial 4 using the same concentrations of S8 and OH as in trial 1, but the reaction occurs at a much slower rate. The student observes that the temperature in the lab is lower than it was the day before. Using particle level reasoning explains 2 explanations that help account for the fact that the reaction is slower. Okay, so remember, temperature affects a reaction in 2 ways. Because the particles are moving slower, you have, number 1, fewer collisions. And number 2, you have a smaller percentage of your molecules have enough energy to overcome the activation energy barrier, right? So fewer collisions and fewer collisions with enough energy, right? So you have fewer collisions and then you have less available energy for a reaction. Let's see what they said. They said the temperature was lower on the second day, so the average kinetic energy of the reactant particles was lower. Therefore, there were fewer collisions. Check. Okay. Since the temperature lowers, the kinetic energy is lower, and the average speed was the particle. At the lower speeds, collided less frequency. Oh, so Oh, there we go. Fewer collisions with sufficient energy. So they say sufficient energy in the first one, and then fewer collisions in the second one. 1 point are earned for valid explanation that affects the energy of the collisions. 1 point are a valid explanation that addresses the effect of the frequency of the collisions. Okay. So remember, temperature affects things in two ways. Concentration just affects the collision, the number of collisions, but temperature affects the number of collisions and the energy of those collisions. That's why temperature has such a massive effect on the rate of a reaction. So 2 points there. Okay, 10 points. How'd we do? How'd we do on the 10 points? Did we get them all? Did we get... Remember, you only had to get 8 if you're shooting for a 5. Hey, good job, Lauren. Good job, Isaac. Good job, Maggie. Yeah. So remember, if you're trying to get a 5, you only have to get 8 of them right. If you're trying to get a 3, you only have to get half the problem right. You only had to get 5 out of these 10 points, right? So hopefully that'll help some of you that maybe didn't do as well as you wanted to, right? So get a 3, you only have to get about 5 of them, 5 out of the 10 points. I feel like an epic chemist. Nice, Logan. Chemist. Okay, cool. That was question 1. Let's look at question 2. So question 2 says, answer the following questions relating to HCl, CH3Cl, and CH3Br. All right, Lauren, let's see how it goes. So HCl can be produced by the reaction of concentrated sulfuric acid with sodium chloride solid is represented by the following equations. Okay, so here's our reaction. Check. A student claims the reaction is a... No, and that might happen on the real AP test, Isaac. I don't know. I have no idea what kind of questions they're going to ask. So, yeah. But you may finish early. And I'm probably a little over preparing you guys, so hopefully you do finish with plenty of time to upload and get things done and submitted. But I'd rather you be over prepared than under prepared. Okay, so HCl. A student claims the reaction is a redox reaction. Is the student correct? Justify your answer. Okay, how are we going to prove if this is a redox reaction or not? We got to look at oxidation numbers. Okay, so if we look here, hydrogen's +1, oxygen's -2, so the sulfur's got to be +6. Here, sodium's +1, chlorine's -1. Here, hydrogen +1 is chlorine's -1, sodium's +1, oxygen's -2, sulfur's +6. Okay, so the oxidation numbers, by my quick little calculation, sorry if that was too fast, but the oxidation numbers do not change. And since the oxidation numbers do not change, this is not a redox reaction. This guy's dumb. Dummy. Students, man. Those students are, I think, anytime that it says like a student claims something, I think probably like 2 out of 3 times he's wrong, and 1 out of 3 he's right. Of all the tests I've looked at. So it's a safe bet to say the student is wrong. For some reason, the people that write the test assume that all the students are idiots. Because they're pompous chemists. Okay. So we say no, it's not correct. We show the oxidation numbers stay constant throughout the reaction. There's no exchanging of electrons. Number 2 says calculate the mass in grams of sodium chloride needed to react with excess sulfuric acid to produce 3 grams of hydrochloric acid. So this is a simple stoichiometry, right? This should have been easy points. So you'd start out blank grams of sodium chloride equals 3 grams of HCl. 36 grams is a mole. From our reaction, 2 moles of HCl require 2 moles of sodium chloride. 1 mole of sodium chloride is 58 grams. You do all the math, done. So let's see. No, the student's not correct. None of the oxidation numbers of the elements change. Check, check. That gives you 1 point. Number 2, do the stoichiometry. You get 4.81. 1 point for determining the number of moles, which may be implicit, right? This is implicit here. 1 point's correct. So this is 2 points. 2 points for an easy stoichiometry. Hopefully you guys got that set up right, and you did that. Stoichiometry, there will probably be a stoichiometry question, and it'll probably be easy, and that's a free at least 1 or 2 points. So you already got 3 points, hopefully. Okay, so 4.81 should be your answer to number 1, or letter A, II. Okay, cool. All right, now we have a new reaction. HCl can react with methanol vapor to produce, what is that, methylchlorine, monochloromethane, something, whatever. Chloroform, chloroform CCl. That's monochloromethane. I don't know what that's called. Anyway, so we've got this reaction. Ooh, they gave us a K, right? So as I'm looking at that problem, I see K, and I think, okay, K means I'm going to do some sort of equilibrium. So letter B. Methanol and HCl combined in a 10-liter sealed reaction vessel allowed to reach equilibrium at 400 Kelvin. The initial partial pressure of the methanol is 0.250, and that of the HCl is 0.60. Does the total pressure in the vessel increase, decrease, or remain the same as equilibrium is approached? Justify your answer in terms of reaction stoichiometry. Say reaction stoichiometry is just a fancy way to say coefficients. Okay, so if we look, right, how many moles of gas do we have on the left? Well, we have 2 moles of gas on the left. How many moles of gas do we have on the right? We have 2 moles of gas. And so any of the gas that's consumed is going to be created, but it's going to be created. 2 of these are going to go away, and 2 of these are going to be formed. And so the total pressure remains unchanged. Okay. Now, if it had been like 1 gas on the left and 3 gases on the right, then the total pressure would go up. If it had been, 3 gases on the left and 1 gas on the right, then the pressure would go down. But because stoichiometry, 2 to 2, it's going to be equal. Now, you could have done an ice table and then shown a minus x and a plus x and added the total and tried to evaluate it with math, but really, if they say reaction stoichiometry, that's a key way to just say, look at the coefficients. Okay. Considering the value of Kp, I tried, but I didn't know what I was doing. That's okay. That's why we're going through it. We're learning, right? Always learning, always reminding things, always learning things. So considering the value of Kp, so Kp is very large. Calculate the final partial pressure of HCl after the system inside the vessel reaches equilibrium at 400 K. This seems like a complicated ice table. You're going to have to use the quadratic to solve this, aren't you? Yeah, you have to use the quadratic. That's gross. Now what you could do, because look at this K. This K is very large. Right? Because the K is very large, we could make some assumptions, right? We know we can do assumptions when K is very large. So let me jot down some info and see if I can help you guys work through this one. This was probably too hard of a problem. And I bet if we look back at the AP scores for this year, I bet a lot of the students missed this problem. Which I actually have that info to see what percentage got the student problem right and what percentage got the student problem wrong. All right, let me jot down an ice table. 0.250, 0.60000. K is 4,700. Ah, these jerks. All right. Let me walk you guys through this. Okay, so because K is so large, we know the reaction is product favored. So we can almost assume that all of this is going to transform first. So we can assume that, let's just take away all of this methanol and turn it into this other stuff. So we get 0.350, 0.250, 0.250. Now, it's not actually going to stay like that. Well, this is a dumb problem. College Board, man. Jerks. Because then we can think about how it shifts back in the other direction. But we can assume x is small. Yeah, we can assume this value is really, really small. I wonder if that gets me the right answer. Right? If we assume that like almost all of it goes away, but a tiny bit gets left over, like small amount. I wonder what we get here. I wonder if this assumption is a valid assumption. 0.250 squared. Yeah, this is going to turn out to be valid. X is 3.8 times 10 to the negative fifth atmospheres. Okay, let me try to explain what I did and why I did it and how I did it. Yeah, Mikey, skipping this was probably actually a great idea. I would have skipped this problem. As soon as you plugged in and said like, oh, minus x, and you found that plus x, and you're like, oh, this is a quadratic, I would have skipped it. Just, you don't need the point. Just skip it. And if you have time, come back to it. So I definitely would have skipped it. All right, so let me show you what I did and how I did it. Because K is so large, we know the reaction is going to be very product favored. And so we know that almost all of this is going to transform. Almost all of it's going to be turning over to here. All right, so I basically said that pretty much all of it changes, and we're going to say this is 0. Now, this isn't really 0. It's just a really small number. And so that's why I say, okay, let's make this a really small number. Not 0, but a very small number. Right? Then we plug this in. We say, okay, here's my very small number. My very small number turns out to be 3.8 times 10 to the negative fifth, which is a small number, meaning that me assuming it was a small number is valid. I don't know if I'm explaining that really well. Let me see what they did. Okay, the pressure remains the same. Sorry, we didn't give you that point. So this was letter I. The pressure is the same. The value of Kp is large. The reaction will proceed to the right until the limiting reactant is essentially used up. Thus, practically all of it will react, and the final pressure of HCl is 0.350. Oh, sorry, I have the wrong screen up. So they asked about HCl, so we would say HCl is 0.3. So you got 1 point for saying the pressure stays the same from the stoichiometry. And then, so that was that other problem. And then on this one, you got 1 point for saying it's 0.350. Okay. Or you could have done an ice table minus x. X is basically say that this is essentially 0. You didn't actually have to find the methanol. You just had to assume that most of this changed. Now, if they had asked you to find the methanol, that would have been a little bit harder. But I don't like this problem. Oh well, I don't get to choose. But again, 1 point, right? Is 1 point worth 10 minutes of your time? No, it's not. So let's go back to it. Letter 3, the student claims that the final pressure of methanol at equilibrium is very small, but not exactly 0. Do we agree? Oh, this time the student's right. Good job, student. This is a smarter student. Do I agree? Yes, I agree, because it's not going to go to 0 because there has to be some of it available. What did they say? They said, agree. The very large Kp means the partial pressure of the limiting reactant at equilibrium will be extremely small, but some must exist for the system to be in equilibrium. Or you could have actually calculated it as 3.8 times 10 to the negative fifth, which we did. The partial pressure is very small, but not 0, right? So you get 1 point. And you can either explain it logically or mathematically. I'm more of a explain it mathematically kind of person. Okay, so point there, point there, point there. All right, let's go back to it. All right, the table shows some data. Okay, if you ever see this dipole moment, that signals your brain to say intermolecular forces. We're talking about intermolecular forces. Okay, so the table below shows some data. We have the molar mass, we have the dipole moment, we have the boiling point, we have the delta H of vaporization. Identify all types of intermolecular forces that exist among the CH3Cl molecules. So, CH3Cl, it's got to have dispersion forces. Everything has dispersion forces. Okay, so it's got dispersion forces. Doesn't have dipole-dipole. Well, is it polar? CH3Cl, it has a dipole moment. It is polar. It is going to have dipole-dipole forces. Does it have hydrogen bonds? Hydrogen bonds, remember, we have to have hydrogen directly bonded to nitrogen, oxygen, or fluorine. There is no hydrogen, or there is a hydrogen, but there's no nitrogen, oxygen, or fluorine, so it cannot show hydrogen bonds. So it's going to have dispersion forces and dipole-dipole. Now I'm betting you had to say both of those to get a point. So let's see. 1 point is earned for identifying both types of forces, dispersion, dipole-dipole. Easy point, but you have to remember that all molecules have dispersion forces. Polar molecules have dipole-dipole. Nitrogen, oxygen, fluorine directly bonded to hydrogen have hydrogen bonds. Okay, so 1 point for saying both of those. In terms of intermolecular forces, explain why the boiling point of the CH3Br is greater than that of CH3Cl. Okay, so if we look at this, this is, again, I feel like every single intermolecular forces question goes against what you would think, because CH3Cl is more polar than CH3Br, so it actually has a stronger dipole-dipole interaction. But because bromine is so much heavier and has so many more electrons and is so much more polarizable, that's our key word here, polarizable, it's going to have a higher boiling point. So the dispersion forces in CH3Br are stronger than the dispersion and dipole-dipole. I guess the combination of dispersion and dipole-dipole in CH3Br is stronger than the combination of dispersion and dipole-dipole in CH3Cl because of the greater polarizability of CH3Br. So it has stronger dispersion forces. Let's see what they said. They said the electron cloud in CH3Br is larger and more polarizable, right? More electrons, more polarizable than that of CH3Cl. As a result, the dispersion forces are stronger in CH3Br compared to those in CH3Cl. Consequently, the boiling point is higher. Okay. More polarizable, stronger, higher boiling points. All right. A 2 milliliter sealed glass vial containing 1 gram sample is stored in a freezer at 233 Kelvin. Calculate the pressure, assuming, so we have a PV equals nRT problem. Our old friend, PV equals nRT. Okay, so let me jot this down. We have 2 milliliters. We have 1 gram of CH3Cl liquid. We've got 233 Kelvin. Okay. Oh, but we're changing to 298 Kelvin, assuming it all turns to a gas. Okay, let's see. We know... Oh, we're calculating pressure. Okay. All right, so let's go through this. So, turn this off. All right. So 1 milliliter, or 2 milliliters, 1 gram. All right, so PV equals nRT. So pressure equals nRT over V. We got to find moles. So let's just do a quick conversion. Do they give us the molar mass anywhere in the problem? No, I have to calculate it. Jerks. 35.5 plus 15 is 50.5 grams in 1 mole. All right, so very small mole value. So whatever that is, let's see. 1 divided by 50.5. So 0.0198 moles times R, 0.08206 liter atmospheres per Kelvin mole, times T, we're up to 298 Kelvin, divided by my volume. Now I gotta, because R is in liters, I have to make sure I put my volume in liters. So 0.002 liters. All right, so let's do the math here. So 0.0198 moles times 0.08206 liter atmospheres per Kelvin mole times 298 divided by 0.002. Oh, whoa, 242 atmospheres. That's a lot of pressure. Like, a lot of pressure. So then the problem kind of tongue-in-cheek asks you, Explain why it would be unsafe to remove the vial from the freezer and leave it on a lab bench at 298. Why would it be unsafe? Do you want to explode? Yeah, basically the idea that 200 atmospheres is way more than glass can handle. Yeah, it's going to explode. Glass is really only safe up to, depending on the glass, maybe like 20 or 30 psi. If you're just talking like a normal glass vial. So this is way too much pressure, and so it could potentially explode. So let's see what they said. They said 242 atmospheres. And then at room temperature, the liquid will vaporize. Consequently, the glass vial may not be strong enough to expand the increase in pressure, which is a boring way to say it's going to explode. All right, so again, 10 points. All right, recap the points on this one. 1 point for saying that it was not redox. 2 points for the stoichiometry. Easy 2 points. 1 point for saying the pressure doesn't stay the same, or pressure stays constant because of the change in the number of moles is the same. 1 point for this overly complicated equilibrium problem. Another point for kind of justifying this equilibrium idea. 1 point for identifying the two intermolecular forces. 1 point for saying more polarizability. 1 point for calculating 242 atmospheres, and then 1 point for saying is going to explode. So how did we do on problem 2? How'd we do on problem 2? 8 out of 10? 6 out of 10? 9 out of 10? That's good, Maggie. 7 out of 10? 16 out of 20 total, Bryce. That is just barely the cutoff for a 5, in my opinion. So again, a reminder, above a 16 or greater, you got to say polarizability when it comes to dispersion forces. So 16 out of 20 is just a breakout for a 5. Good. 13 is the breaking point for a 4. So as long as you got 13, you're good for a 4. If you got 10 or higher, that's a 3. So again, some of you that are just looking to pass, 10 or greater is all you needed. All you needed were 10 of these points. You just have to get half of the problems right. Hopefully that'll lower the stress, lower the anxiety. 15, look, Sammy, that's a 4. That's fantastic. Okay, that's so close. That's almost a 5, right? So keep that in mind. Just understand that you don't have to get every question right, right? You can skip a question and be okay. Yeah, I'm going to, Logan. I'm gonna post those this afternoon. So if you haven't finished this yet, go ahead and do it tonight. And then I'm going to post these keys so you guys can have them to look over and to even study if you want. So what I want to do for the last 5-10 minutes, good job, Zach. What do you guys want to do Wednesday? I know some of you have AP tests that you're going to be preparing for and studying for, so I don't want to do anything like essential. But for those of you that can make it on Wednesday, what do we want to do? Do we want to do more practice problems? Do we want to do you want to talk through the cheat sheets? Do you want to, we can do all kinds of things. Do we want to do like a topic discussion? Yeah, because I have more practice problems. I can try to find some hard ones. Yeah, so like I said, I know a bunch of you won't be here Wednesday. I will post the stream kind of right after on Wednesday, so you can look at it Wednesday night as kind of a last study effort. But yeah, so maybe more practice problems, maybe harder practice problems. Are there any topics that you're still feeling uncertain on and you want more review on, specifically? Are there any topics that you still just keep getting wrong, and even in your review books you're still struggling with? I see. Yeah, I think equilibrium. Lauren, I think equilibrium would be actually really good to go through. So I'm gonna pull out a couple equilibrium problems that we can run through and go through. Yeah, equilibrium. I think that's a good idea. I think equilibrium is a great idea to talk about, because when we ended school, we were so focused on doing like buffers and things like that we didn't have to do it. So yeah, Maggie, so Bryce, for turning your review books, I really just want you guys to post a video of you just like flipping through your book. So just, you're like, hey, look, here's my review book, Mr. Gillespie. Look at all this work I did. Okay, and just like a quick 10-second video is all I need, and then we'll just upload that to Canvas so I can just see you guys did it. So like KSP, Sammy? That kind of fits under the umbrella of equilibrium. So we could do those. Someone messaged me. Oh, no one important. Okay, Lauren, it sounds like you've got some review book to work on. Do you have other AP classes? I hope not. Or at least I hope not too many. Okay, so this week and next week I know is going to be really stressful for a lot of you guys. So, okay, AP Lang. Is Lang tomorrow? Lang is next week. Okay. All right, so I think Lit is tomorrow, or is Lit on Wednesday? Calc is tomorrow, yeah. Yeah, so for those of you in Calc, for sure, today, focus on Calc. After the Calc exam, go full chemistry until Thursday. Oh, you have 8. Oh, some of you have 3 this week. I'm so sorry. I'm so sorry. But you can do it. I believe. Is AB not until later, Sammy? I thought they would run them close to the same time. Oh, Euros Wednesday. That's fine, Isaac. Lit is Wednesday too. Yeah. So, like I said, you guys have a lot of tests. Maybe give Chem a half hour a day, but then definitely focus on your other ones. Yeah. So do for sure try to just breathe this week. Take some time every day to just get out and take a break, but you do have to study hard. Yeah, it's gonna be a rough 2 weeks, but then you're done, right? So, yeah, it's on the College Board website, Isabel. I just didn't have it up to reference it. So people should be able to find it. So let me tell you what I'm going to do. I'm going to upload both of these. No, Lauren, I'm not supposed to do anything. Maybe I'll just have like some fun stuff. We'll talk about that Friday. So Friday we're going to do kind of like a just like unwind stream. We'll talk about the AP test. We'll talk about how you guys felt about it, if there was anything stupid on it. Sorry, Lockmini, I'm not doing any OChem today. Organic's not really part of the... this is more freshman chem stuff. What if we review your leave behind? Joel, just get done as much as you can, and if you want to turn it in like next week, that's totally fine. I want them turned in Wednesday night, Maggie, if possible. But if you want to just keep working in them, then you can turn them in next week. I'll post that today, and we can talk about it Wednesday. Yeah, do a lo-fi chem stream. I'll have some lo-fi in the background on Friday. Friday we'll just chill. We'll just take it easy. But I still am planning on streaming Friday. I'm not doing anything after that. No textbooks. The Masterton Hurley books. Oh, your books. Oh, textbooks. I'm so dumb. Sorry. Thanks, Isaac. So you'll be turning in all of your textbooks next Wednesday. So starting next Wednesday, the 20th of May, they're going to do textbook returns and drop-offs at the school. Yeah, sorry, Maggie. So starting next, I think they're doing seniors on Wednesday, juniors on Thursday, and then freshmen and sophomores on Friday. In terms of turning in textbooks, they're gonna send out a schedule. Yeah, library books too. So they're gonna send out a schedule for that sometime this week. Expect to see an email or an announcement from your Sky Alert or on Skyward or something from Miss Bates that'll detail some returning stuff. Thanks, Just. Appreciate it. Poochie, appreciate it. Library book like January. No, it's fine, Lauren. Miss Bates is understandable. She understands. But I'm going to go ahead and end the stream today, guys. Study, breathe. I really feel for you, and I wish there was more I could do. Let me know what else I can do. Let me know if you need more help in Discord. I'm going to be there this afternoon. I hope I've done enough to prepare you guys. I hope after Wednesday that you guys feel confident. And so hopefully it goes well. Have a wonderful day. I will talk to some of you this afternoon maybe, and then for sure I'll see you guys on Wednesday. If you want a little bit of a break from studying, the esports team does have a match tomorrow that you can tune in for. I'll be streaming that on my channel too. So we're going to be playing Weber Innovation or Bonneville Academy, so we can beat up on some charter school tomorrow. Play some charter school tomorrow. Okay, have a good day, guys. I'm going to wrap it up. Let me know if you have any other questions. I'll get gradebook and all this other stuff updated this afternoon. Bye.